Hello, welcome back to my channel Speak with Math. Find the area of the curve r square is equal to a square cos 2 theta. To find the area of the curve, we can use the equation a is equal to 1 by 2 into integral theta 1 to theta 2 r square d theta, because the given equation is of the form r is equal to a function of theta. And the equation is r square is equal to a square cos 2 theta. And if we change theta by minus theta, we can see that the given equation has no change. If we change theta by minus theta, this equation becomes r square is equal to a square into cos of minus 2 theta, and cos of minus theta is cos theta itself. So, if we change theta by minus theta, it does not alter the given equation. Similarly, if we change r by minus r, then also the given equation has no change. Here the power of r is 2. So, if we change r by minus r, it does not alter the given equation. If the equation of the curve remains unchanged with the change of the sign of r and theta, then the curve is symmetrical about the line theta is equal to pi by 2. So, the given curve is symmetric about the line theta is equal to pi by 2. Since if we change theta by minus theta and r by minus r, it does not alter the equation of the curve. So, the curve is symmetric about the line theta is equal to pi by 2. And if we change theta by minus theta, it does not alter the equation, then the curve is symmetric about the initial line. Symmetric about the initial line also. Now, the given equation can be written as r square divided by a square is equal to cos 2 theta. I just take a square to LHS, that is r square divided by a square is equal to cos 2 theta. Since r square by a square is always non-negative, since the power of r and a is 2, so this is always non-negative. So, cos 2 theta is greater than or equal to 0. This implies 0 less than or equal to 2 theta less than or is equal to pi by 2, and this implies what? 0 less than or is equal to theta less than or equal to pi by 4. Hence, in the region theta is equal to 0 and theta is equal to pi by 2, the curve has real portion between theta is equal to 0 and theta is equal to pi by 4. The curve has real portion from theta is equal to 0 and theta is equal to pi by 4, and no real parts between theta is equal to pi by 4 and theta is equal to pi by 2. That is, from theta is equal to 0 and theta is equal to pi by 2, the curve has real portion between theta is equal to 0 and theta is equal to pi by 4, and has no real portion from theta is equal to pi by 4 to theta is equal to pi by 2. When theta varies from 0 to pi by 4, theta varies from 0 to pi by 4, r varies from a to 0. When theta is equal to 0, cos 0 is 1. Then r square is equal to a square and r is equal to a. When theta is equal to pi by 6, 2 theta is what? Pi by 3. And cos pi by 3 is 1 by 2. That is r square is equal to a square by 2 and r is a by root 2. And if theta is equal to pi by 4, cos of 2 pi by 4 is cos pi by 2. Cos pi by 2 is 0, then value of r is 0. Using the symmetry about the initial line, there will be a loop between theta is equal to minus pi by 4 and theta is equal to pi by 4. Theta is equal to pi by 4 is here and theta is equal to minus pi by 4 means here. So, in between theta is equal to minus pi by 4 and theta is equal to pi by 4, we have one loop. Again, using the symmetry about theta is equal to pi by 2, there is also one loop on the left of theta is equal to pi by 2. On the left of theta is equal to pi by 2, starting from theta is equal to 3 pi by 4 and theta is equal to 5 pi by 4. That is this loop. So, using the symmetry about the line theta is equal to pi by 2, there is one loop from theta is equal to minus pi by 4 and theta is equal to pi by 4, and on the left side also one loop from theta is equal to 3 pi by 4 and theta is equal to 5 pi by 4. Hence, there are two loops for the given curve. Hence, the required area is area enclosed by the two loops. So, by the symmetry about the initial line and the line theta is equal to pi by 2, the required area is 4 times the area enclosed by the portion in the first quadrant of the curve, that is this portion. Area in the first quadrant. 4 times area in the first quadrant gives the complete area of the curve. Using the symmetry about the initial line and using the symmetry about theta is equal to pi by 2, we have 4 symmetrical portions, 1, 2, 3 and 4. So, to find the complete area of the curve, that is 4 times the area enclosed in the first quadrant, that is area A is equal to 4 times 1 by 2 into integral 0 to pi by 4 r square d theta. Here the limits of integration varying from 0 to theta is equal to 0 to theta is equal to pi by 4. There is no real parts for the curve from theta is equal to pi by 4 to theta is equal to pi by 2. So, in the first quadrant, value of theta varies from theta is equal to 0 to theta is equal to pi by 4. 4 into that area gives the complete area, that is the required area of the curve. That is 2 into integral 0 to pi by 4 r square d theta. R square is a square cos 2 theta into d theta. This is equal to 2a square into integral cos 2 theta d theta is sin 2 theta divided by 2. Limits varying from 0 to pi by 4. Here, if we apply the upper limit, sin 2 into pi by 4, that is sin pi by 2. Sin pi by 2 is 1. So, 2 by 2 will cancel, a square into sin 2 into pi by 4 minus sin 0. If we apply the lower limit, this becomes 0. This a square into sin 2 pi by 4 is sin pi by 2 minus sin 0 is 0. Sin pi by 2 is 1. That is a square. So, the required area is a square unit square. So, the required area, that is the area of the curve r square is equal to a square cos 2 theta is a square. Thank you.